Today we're going to be talking about rational numbers. Last week we talked about integers, and integers are also rational numbers, so this is a good segue into this. So we're going to start by titling our notebook entry. You need to be doing this too because you're going to submit a picture to me after this so I can see your notebook entry. So you need to title it Rational Numbers. And we'll be working with rational numbers for a while because there's lots of different facets of these rational numbers. And this will be your third notebook entry. Now you need to have this either in a notebook or on paper that has holes so you can keep it in your binder. And I know I'll be getting my traditional students back 4 days a week next week, and I'm really excited to see you. And you'll need this notebook entry to help you. You can reference it while you're working on your work during class. So rational numbers. First of all, what is a rational number? So let's define it first. Rational numbers they're any number that can be found on a number line. They can be represented as P over Q, where Q is not 0. I know what you're thinking. What? That's what you're thinking. What is this P over Q? P over Q is just a way for us to represent any fraction. These are called variables. They're not numbers. They're letters that represent unknown numbers. So we know that numbers are infinite. So if we were born and we started writing numbers and we wrote numbers our entire life, we would still not have written down all the numbers when we died. So this is just a way for us to represent that any number, so this would be your numerator is your P and your denominator is your Q. And your denominator cannot be 0. It is not rational if it's not 0. So why? Why can it not be 0? Let's just make us a little note. Why can Q not be 0? Well, this is why. If you have a fraction 3 over 0, there is nothing that you can multiply times 0. Nothing times 0 equals 3. Therefore, it is not rational. Okay, there's your little side note on why can Q not be 0? Nothing times, and that sounds like a good test question to me. So that might be something you might want to think about. Okay, so if rational numbers can be represented on a number line, what can rational numbers be? Let's go ahead and draw us a number line. And I'm going to put my 0 in the middle. And I'm going to kind of space out my numbers here because we're going to be talking about what would be in between all of these numbers. Okay, so rational numbers can be integers. And I'm just going to make a note down here. Rational numbers can be, and I'm going to put 3 dots because that means I'm going to put a little list down here. They can be integers. They can be fractions. They can be decimals. And they can be some square roots, but not all square roots. Okay, let me go back to my red. Rational numbers can be integers. So let's write a few integers down. They can be any integers. So integers can be represented as 0. They can be represented as positive numbers. I'm just going to put positive 2. They can be represented as negative numbers. Now, I want you to notice that rational numbers are only rational if they can be represented as a fraction. How do we represent whole numbers as a fraction? So, if I represent my whole numbers as a fraction, I could represent 0 as 0 over 1. I could represent positive 2 as positive 2 over 1. And I could represent negative 4 as negative 4 over 1. So those can all be represented as fractions. Now, really, I could just write these here, but I'm just going to write random fractions. So I could have positive 3/4. I could have negative 2/3. Any fraction you can list as long as the denominator is not 0. Let's look at these decimals. Okay, so we can have decimals, and decimals are 0.5. We can have 1.33, and it's repeating. That means this is terminating and this is repeating. We can have positive 0.25. How could I represent these as fractions? Well, this says 5/10, so I could write it like this. This says 1 33 hundredths repeating, so that would be written as 4/3. And this says positive 0.25, so that could be written as 25 hundredths. So all of those could be represented, and they could be positive or negative. And we have one more, and that is square roots. The square root of 4. And I said some of them, not all of them. What is a square root? Well, this just means that something times itself equals 4. So I know that 2 times 2 equals 4. So the square root of 4 is 2. And we have like the square root of 9. That would be 3 times 3. So the square root of 9 is 3. And of course, 2 could be written as a fraction as 2 over 1. 3 could be written as a fraction as 3 over 1. So these could all be written as a fraction. And of course, they could be negative also. I have someone at my door. Let me see if I can pause this. I can't. Okay, I'm back. I had a parent at my door. I had to go give them their progress report. So I am back, and let's talk about how we would see these on a number line. So we know that these are our whole numbers. And in between each whole number is an infinite amount of numbers. They're fractions, they're decimals, they're square roots. There's all kinds of numbers in between each number. So we know that if we wanted to put, let's say we have the integer 2, that we can see it right here. That's on the number line. If we wanted to show the fraction 3/4 on the number line, we know that that means that there's from here to here, from here to here, and from here to here. So 3/4 would be right here. So it's also on the number line. We know that if we wanted to see where 2/3 was, it would be 1/3, 2/3. This would be where negative 2/3 would be. It would be before the 1. If we wanted to put decimals on our number line, I know that 5/10 here is the same thing as 1/2. So if I wanted to see my decimal on the number line, I know it would be right here. And if I wanted to see my square root on the number line, square root of 4 is 2. So this would also be on the number line. All of these things are on the number line. And of course, you know, if you had a mixed fraction and if it was 3 3/4, it would be here. We could put 3/4. Let me see what color my fractions are. They're pink. So if I had 3 3/4, that I would go to 3, 1/4, 2/4, 3/4. So this would be 3 3/4 here. And if I had negative 2 2/3, it would be here, found on the number line. So just think about that number line and how you know that there's numbers in between all these other numbers. These whole numbers, there's lots of numbers in between. You just have to go with what you know. Okay, so if it can be found on the number line, positive or negative, and it does not have a denominator of 0, then you have a rational number. All right, so this is what I need your notebook entry to say. I need a picture of it inserted on your Google Drive. I'll give you an assignment where you show me your notebook entry, and I'll have another video to show you what we're going to do today. We're going to add and subtract decimals because it's the most like whole numbers, and then we'll move, I'm sorry, not whole numbers. It's the most like integers, and then we'll move on to adding fractions on Friday. Good luck with this. If you need to pause it and get it copied, please do. If you need to back it up, please do. Use these videos to your advantage. Bye-bye.